pitch.
Are you already recording?
Everything's okay. Okay, there, it's on.
Oh, this is recording.
And now I pulled it. Okay, how
Oh my gosh.
there's still stuff on the side. Oh, good lord.
Does it feel cold? It's cold.
It didn't go all the way up.
Is that it?
Do you feel the temperature?
Yes, it's cold. There's stuff on the side that's not going in, I guess.
Okay, so the reaction was an endothermic reaction, meaning that it's
Heat absorbing and
it bubbled up and it went into this balloon, and like the carbon dioxide that formed went into the balloon, and the salt water stayed underneath.
Also, the temperature got colder, so
Yeah. We could change the experiment by either getting more acid or getting more powerful acid, which would create more gas. So that's a thing. So two sources of error is that the balloon is like really hard to measure, like it keeps moving around, so we can't really get an exact measurement of CO2. And then also the baking soda also didn't get out of the balloon, so that's not good.
and that would be a reason for why we didn't get 100% yields in our experiment.
And then also, some of the gas could have escaped from the balloon while we were taking it off of the Erlenmeyer mask or whatever it's called. Or flask. I don't know why I said mask. Sorry. So, yeah. Is that it? No, I think we're done.
Calculations and working.
Well, that's the sheet. That's the sheet. So, bye.
In order to find out which reactant was limiting and which was excess, we used stoichiometry. First, we calculated how much carbon dioxide could be made out of each reactant by multiplying the proper conversion factors together. First, we multiplied the amount of hydrochloric acid we used in the experiment by the ratios from the acid's volume to its moles to the moles of the carbon dioxide to the grams of carbon dioxide to find out how much carbon dioxide the hydrochloric acid could make. Then we did the same for baking soda. While the baking soda was able to produce 5.24 grams of CO2, hydrochloric acid could only make 4.4 grams of CO2, meaning that the hydrochloric acid is the limiting reactant, and baking soda is the excess. We then figured out how much baking soda was left in excess by working backwards. We subtracted the final grams of CO2 and ended up with 0.84 grams of CO2, and multiplied that number by the ratio of grams to moles, the ratio from CO2 to NaHCO2, and the ratio from moles to grams to get the amount of excess, 1.93 grams of baking soda.